Very good morning, I'm Essential. And myself, Tamil Selvi, belongs to Electrical Electronics Engineering Department, working as an assistant professor in Erode Cylinder Engineering College. Okay. Today, in gate class of under the scheme of AICTE PRERANA scheme for preparing the gate for SC/ST students for their higher education, I'm going to deals with about the circuit theory subject, and we're going to discuss about the mesh analysis topic. So we just move to the topic. Our topic is today mesh analysis. So first of all, we have to we already discussed the basic terminologies and what is meant by mesh. Mesh, it is in a closed loop. A mesh or a loop is a set of branches which is forming as a closed path in a network. In that network, it's just forming a complete branches are covered in a closed path. That is only called as an mesh. Okay, and a mesh does not contain a loop, but a loop does contain an n number of meshes. Okay, this is the main difference between the mesh and the loop. So in this case, one branch is removed, then the remaining branches do not form a closed path. That is called as a mesh or a loop. So both are same, but the one simple difference is a mesh does not contain a loop, but a loop which contains a mesh. Right? So in this case, a loop also can be defined as a closed path which should be originate from a particular node, and that from that node itself it is terminating. The terminating node is also same. So if we having a see, so this is in case this is a network, right? So in this network, see, a circle, this is a loop. But in this loop, we consist of having n number of meshes here. Okay, so this is mesh 1, mesh 2. Okay, inside is n number of meshes. Totally, we having the two meshes which is present inside the loop. But a mesh does not contain the loop. Okay, so and another difference is if a loop which originates at the point A, see, if in case this point is an A, in this point, it is a starting point. If it is in a loop, in that same point, the current will be terminating there. Okay? The starting point and terminating point is both are same in loop, whereas mesh not in that case. That only be say that clearly a loop which defined as an it is also a closed path which originate from a particular node and terminate at the same node itself. Where it should be originated at that node itself, it is also terminated. So the traveling through the various other nodes without traveling through any node as twice. Okay, and the next important thing, the mesh method, which uses the mesh current method. The mesh method is mainly used to analyze the current in a particular mesh circuit. Okay, so the mesh method, which is used for finding the current, so it is called as a mesh current method. So mesh current as the circuit variables, right? So in this case, the procedure for obtaining this solution is in the various steps. We are going to follow some various steps to finding the particular current. Okay. So this mesh method is mainly used to analyze the current. So that's why it is called as a mesh current method or mesh analysis method. So for finding the current value, uh, we have to follow some of these steps, right? So first, for that, the first step is clearly label all the circuit parameters and distinguish the unknown parameters from the known one. So we have to, for that first thing, we have to label all the circuit parameters, that is in case of a resistance value, right? voltage source, current source, whether what type of source they are given. So we have to clearly label the each and every parameters and clearly picturize, draw the circuit, and then distinguish the which one is an unknown parameter from that particular circuit. So that is the first thing. Then from that case, after drawing the circuit, then you have to identify the all messes of a circuit. So in that circuit, which is a mess and which is a loop, you have to identify that. Then you have to assign the mesh current and label their polarities, right? So we have to assign mesh current direction with the direction and have to label with polarities, positive or negative, where it come positive, where it come negative. So you have to label their polarities. Then apply the KVL law in each meshes. So in case in this circuit we having the three meshes. So mesh 1, mesh 2, mesh 3. So three meshes are present. In that case, you have to apply the KVL law in each meshes. At first mesh, then you have to apply the KVL law at second mesh, and then you can apply in the third mesh. So in individual each meshes, we have to apply the KVL law, and then by applying that law, we have to express the equation in terms of voltage. Okay, express the voltages in terms of mesh current. Okay, that is where I1 plus I2 plus I3, which is equal to the total voltage V. Okay, that is, we know what is in KVL law. Your KVL, we having the Kirchhoff's voltage law and Kirchhoff's current law. Your Kirchhoff's voltage law, the sum of potential rise is equal to sum of the potential drop. This is the one other form, first form. And the second case we can also express in that the algebraic sum of the EMF present in the closed path is equal to 0. Right? The algebraic sum of the EMFs in a closed path is equal to 0. That is another form. So we have to supply the KVL law. From that KVL law, you just equate that. Form the equation. That equation should be in terms of mesh current. That is where R11 into I1 plus R12 into I2 plus R13 into I3, which is equal to the total voltage V. So the potential drop will be expressed in terms of R into I. Potential drop, we know where EMF, which is nothing else than V is equal to IR. So based on that, I in the form of IR is equal to V. In that form, we have to express the voltage. We have to express the equation, KVL equation in terms of mesh current. And we have to solve the resulting simultaneous equation method. So we are all studied in mathematics. That is, I'm solving the simultaneous equations. So based on that, you just solve the equation for mesh current. And then mesh currents are a known one, and the voltages can be obtained by using a Ohm's law. So now you can find mesh currents are known and the voltages may obtained from your Ohm's law, right? So the next, for example, you just consider this circuit diagram. In this circuit diagram, a mesh is defined as a loop which does not contain any other loops, but it contains the two meshes, right? Our circuit this as an example which has a three loops, right? So you just consider as a three loops inside it. Okay. So but only two meshes are here. Three loops. The outer one loop, another one loop. The rounds will circulate it as an loops, and the circuit and the box structure will represent the meshes, right? So the mesh of which having mesh 1 and mesh 2. Totally it having two meshes, but it can having the three loops. Okay. So for the next step, we will assign the mesh current, right? We just assigning the mesh current, define current direction and the voltage polarities. Okay. So for the next step, we will assigning the mesh current. Okay, for we just first determine which one is a mesh. Here we having the two meshes, and the next thing, for the mesh we have to assign the current direction, and we have to give the polarities for the voltage sources. So here they just giving you a single voltage source only Vs. For this Vs you have to assign the polarity. So see this small line which represents in the battery as a negative, and this one will be represented as a positive. So this is the polarities, positive negative polarities for the voltage source. And then you have to assign the, right, assign the current direction. Your current direction, we just only assuming the current direction. So for that you just keep in mind, you must to assign the current always in the clockwise direction. Okay, not in anti-clockwise direction. You must to assign the current in clockwise direction. So let us see here the direction of the mesh currents where I1 and I2 is defined in the clockwise direction. That is mesh 1 which is in clockwise direction I1. For I2 in mesh 2 the I2 current is flowing, that is also flowing in the clockwise direction, right? So from this case, see, so this will define for the current direction is an arbitrary, but which helps if we maintain a consistency in the way we define these current directions. So consistency, we have to define the current direction only in the clockwise direction, depends upon the arbitrary action. Okay. So note that in a certain parts of the mesh, the branch current may be same as the current in mesh. See, so as like at I1, this I1 only be flowing in this branch. So this R1 is present now. R1, this is one branch, and R2 this will be another branch, and this is one branch, right? So at what current is flowing through this way is the same as in this branch. Okay. So here, in case if the current 5 amps is flowing this way, means the 5 amps of current is only flowing through this R1 resistance in this branch also. Then only after reaching this point, then only the 5 amps of current will be split into two ways, this direction and then this direction. Okay, so that is certain parts of a mesh, the branch current may be same as the current in the mesh, right? So the branch of the circuit which containing resistor. Okay, so the branch of a circuit which containing the resistor R2 is shared by the two meshes, and thus the branch current. Okay, so the branch of a circuit which can see, this is the R2. In this branch, the two currents are flowing. One current is I1. I1 is flowing from top to bottom, and another current which is I2. I2 is flowing from down to top, right? So both the current will be flowing in opposite direction. So that's when we expect the branch of certain contain resistors R2 is shared by the two mesh currents. One is I1 and another I2, right? So in this case, the branch current, the current flowing through the R2 is difference of the two mesh currents. So if in this case, in this type of cases, both the both currents will be flowing in the same branch in opposite direction, means we have to take that and of difference of the two mesh currents. Okay. So in this case, let note that in order to distinguish between these two mesh currents and the branch currents, which are using the symbol of capital I for mesh current and the symbol of I for branch current, you have to know the difference. So for mesh current, see, for mesh current, so this mesh current will be represented in terms of capital I, and the branch current, this branch, okay, R2 present here, this is a branch. So when the current is flowing through this branch, means that will be represented as a I, right? And the next case, okay, Are you understand this? In the next case, let you consider the Miss 1. Okay? Let just you consider the Miss 1. In this case, you must to carry the all the information of these shared branches. So for Miss 1, the branches which should be interconnect with the current I1. Okay. Here we indicate the direction of Miss current I2 on the shared branch. Okay. So on the shared branch. So I1 is in I1 is flowing through the branches are R1 branch and R2 branch. So our R2 branch is shared I1 as well as I2. Both the current is flowing through this branch. So for this case, first, you consider first miss. You just apply the KVL to the miss one, and starting at the upper left corner, you have to start at this case. In this case, always you must to start in this case, or in another way, you can just take it where the voltage source is present. Okay, from that point you must to see. So in this case, the potential rise means for the potential rise, the polarity will be flows from negative to positive. So when the polarity rise means you have to negative to positive, the charges flow, then only the potential will be rise, right? So after the potential rise, then only the charges are move in the particular branches. So in that case, you take you will consider in that case you just consider. So from that the for writing the equation we have to start at the point of upper left corner and proceeding in the clockwise direction. Okay, so the sum of voltage across the all elements encountered is where Vs equal to I1 R1. See here, Vs equal to I1. So in this branch is V1. So for instead of V1, we can written as I1 into R1. V equal to IR basis, that is based upon the Ohm's law. We have written that as I1 into R1. Then come to here. The next branch is plus minus. So in this case, in plus minus, I1 is flowing as well as I2 is also flowing. So both is in opposite direction. So in this case, the two currents are flowing in the opposite direction. Then we can written as I1 minus I2. Okay. So for which message we are considering, that current should be taken here as the first one. So that's why here we just represented I1 minus I2 into the R value is R2. Okay. So that's why the formation of this equation where Vs equal to I1 R1 plus I1 minus I2 into R2. Okay. So then I1 R1 plus I1 minus I2 into R2 minus Vs is equal to 0. So you just rearranging this equation and equate this equation to 0, that is I1 R1 plus I1 minus I2 into R2 minus of Vs equal to 0. So then you just apply the KVL to mesh 2. So you same thing, base the same procedure. Next, we applying the mesh equation, that's KVL equation in second mesh. So in this equation, see that you just consider the second mesh, applying the KVL. So here also you will start at upper right here, because here there is a no voltage source, but the potential will be maybe rise here, means in this way only it will be rise. So from that you just take as upper right corner and proceeding this in a clockwise direction, the sum of the voltage across the elements which are encountered here as same as like as same previous one. Here you just write where I2 is the current which is flowing in the both the resistors R3 and R4. So I2 into of R3 plus R4 plus. So we having in this branch the two currents are flowing. One is I1, another one is an I2. So for we now we considering the second mesh. So which mesh we are considering for that same current should be considered in the first cases. So here I2 minus I1 into R2, which is equal to 0. Because in previous there is a no there is a having a voltage source in this one, but in this case there is a no voltage source, so we just set as a 0, so that's it will be equal to 0. So keep in mind that unknown of the problem or the mesh current only, other than that nothing. Okay, so you have to determine only I1 and I2. So I2 we write in mesh equation form as, so see, we just forming the equation, second equation, and previous one. This is a first equation. Totally, we just form the two equations here. Based on that, so I1 of R1 plus R2 minus I2 into R2, which is equal to Vs. So based on this equation, see here when you multiply this, I1 R2 minus I2 R2 minus Vs equal to 0. So you just rearrange this equation, we can get that I1 of R1 plus R2 minus of I2 into R2 is equal to Vs. And in another case, in second mesh, let you consider the second case. In this case, see minus I1 R2 plus I2 of R2 plus R3 plus R4, which is equal to 0. So by using this equation, let's using the Karmas method, that is Karmas rule. Based on that rule, you just apply a 2 cross 2 matrix. Okay, 2 cross 2 matrix form. In this form, the coefficient of I1 and coefficient of I1 and I2 will be taken here. That is the coefficient of I1 is in the first row first column, that is R1 plus R2, and the coefficient of I2 is minus R2. And let's here in this equation also the coefficient of I1 is minus R2, and here that the coefficient of I2 is R2 plus R3 plus R4. So this is unknown value, so that will be taken as one thing, one matrix I1, I2, and which is equal to Vs is a voltage source present in the voltage source, which should be present. See, voltage in this equation you just consider that Vs is the voltage source which is present in the first mesh, right? So that's why here it is mentioned Vs, and this is equal to 0. Okay, based on that, see here. So here I1 is flowing, in this case I2, and this way is I3. So I1 is equal to mesh current I1, and whereas I2 is equal to I1 minus I2. I2 minus I1. Sorry, for I2 you can write I1 minus I2, and whereas I3 is equal to nothing as an I2. Okay. So the next thing, so based on this, we can solve the problem. See the problem. The problem is you have to find the mesh current. So all the parameters are given. By that, by that parameters, you have to determine the mesh current, right? So in this, see the first step. Here we having the two meshes. This is a mesh 1 and mesh 2. For that meshes, we have to determine the current direction and the polarity for the voltage sources. So the current direction is always, it must be choose in anti-clockwise, clockwise direction. The miscurrent does not flow in the anti-clockwise direction, right? For our assumption, it always must be flow in clockwise direction, right? So from that equation, we just forming the equation as 10 is equal to see 50. So here for I1, this is a direct method. Okay, so this is a direct method. By using the direct method only, we just forming the equation. Based on the equation, uh, we may solve the problem by using a Karmas rule also. Okay. So from that, the current I1 is going through the two resistors 10 and 40. So based on that method, we can easily calculate inspection method. We can easily calculate it. So totally we having here 40 and 10. So it becomes 40 plus 10, right? So as well as the current, two currents are flowing through this branch. So I1 and I2. So totally we having the two currents. Both are flowing in opposite direction. So that based on that, we just forming the equation as 10, 10 equal to 50 I1 minus 40 I2. So this is an equation 1. And same, you just apply the KVL in second equation. In the second equation, in second mesh, based on the second mesh, we can form the another equation as minus 20 is equal to minus 40 I1 plus 60 I2. So see here we having the two voltage sources. How we can start to analyzing this means, you have to start at the left upper corner, and for mesh 2 you have to start at the right upper corner, right? Are you clear in this? So we have to start the uh, start the start the point at left upper corner and proceed with I1. So here the equation which becomes 10 I1, and here when it comes to this branch, it will be changes into 40 into I1 minus I2, then which is equal to minus 10. So when equating that equation, you can get this equation, first equation. And for second equation, you have to consider the second mesh. In the second mesh, uh, we have to determine, we just start at the right upper right corner. From that, uh, 20 into I2, and here I2 minus I1 into 40, which is equal to minus 20. The same case, minus 20. So based on that, you just forming the equation, that is minus 20 equal to 40 I1 plus 40 I1 plus uh, 60 I2, right? So this is the second equation. Okay. So when you're solving this equation by equation solving method, or in another case by using a Karmas tool in matrix method, so whatever it may be, either which one is the best adaptable, we can use that method. So it's just having the two parameters, two variables, only unknown variables here. So for that you can easily find, commonly you can divide this by tens, okay, or 5s. You may be divided by tens, it becomes 1 equal to 5 I1 minus 4 I2, and here 2 is equal to 4 I1 plus 6 I2, right? So commonly it will be divided by tens. Then after that, by equation solving method, we may be solve. So by solving that, you can get the value of I1 is equal to minus 0.143, and I2 is minus 0.429 ampere. So see here, where I1 is minus 0.143 and where I2 is minus 0.429 ampere means, then the current, we just taken a current flowing in the direction is clockwise direction. Let be taken, right? So we assume that the current direction is flowing in opposite direction, but as per the answer solution, they just given only in negative. So your I1 is in reverse direction, that is flowing in anti-clockwise direction, and as well as your I2 is also flowing in anti-clockwise direction. So the sum of the current which is flowing in this branch, okay, that is 40 ohm present in the circuit, that branch, how much current will be flowing? So we just determine I1 and I2. So how much current is flowing through this branch? 40 ohm of resistance branch means you just taken both the current direction. Okay, so let I1 is negative, I2 is also in negative, so it is both should be is in anti-clockwise direction. If anti-clockwise direction means, so in this branch they may become a, so this current is flowing through this direction and this current is flowing through this direction. So I1 is flowing from bottom to top and I2 is flowing from top to bottom. So both the current are in opposite direction. So that for that cases, you have to determine and another current I3, where I3 is equal to nothing as I1 minus I2. So for finding that I1 minus I2, we can get the value of I3, or in some cases you can find that the current flowing through this 40 ohm resistance branch. Okay, so this is a sample problem. By like this problem only may ask, but no need to take too much of time to solving this equation. So as a simple tricks or having, by using that simple tricks, simple methods easily. For mesh analysis method, you just use adaptively. You just use a mesh inspection method. By using that mesh inspection method, within a fraction of minutes, you maybe solve that. By that, it is very helpful to determining this particular unknown variables. In another case, the variables may be given. Here they just given a directly question as an 10 ohm, 20 ohm and 40 ohm. In some other cases, they may be give here as an resistance R ohm, R1 and R2. For that, you have to form a matrix. Okay. So like forming the equation, as like as we have to form the matrix form. That matrix form only be the solution to finding that proper mesh analysis method. Right. And so this is a sample problem for mesh analysis method. So based on under this topic, they may be asked one or two questions, two, three questions they will be asked under this mesh current analysis method. So from this, you have to determine the current value. By using the current value, we can also determine voltage. So what is the question should be they just given. So understand the question and then answer and give a solution for that question. And so there in case for mesh analysis method, we have to prominently we just finding the only the mesh current value. In that mesh current value, based on the mesh current value, we can determine either voltage or power, whatever it may be, we may be find. Okay. Okay. Uh, So up to this, we just see the mesh analysis method and basics. So next class, we just discuss about the nodal analysis method. Up to this, we just stop the session today. And in next session, we can study and we can discuss about the nodal analysis method. Based on the nodal analysis method, we may be solve the problems. Thank you. Thank you.